Good morning, children. In the last video, we have solved some problems, right? This video also, we are going to solve some problems only. Okay, so this session fully we are going to solve problems, right? First, we can start with calculation of relative molecular mass, right? See the question. First one, we are going to calculate the relative molecular mass. So, relative molecular mass of sulfuric acid. What is the formula of sulfuric acid? The formula of sulfuric acid is H2SO4. Okay. So, it contains hydrogen atoms, sulfur atoms as well as oxygen atoms. The formula is H2SO4. It means sulfuric acid. So, the relative molecular mass of sulfuric acid we are going to find out. We are going to find out the relative molecular mass of sulfuric acid, right? So, first we have to identify the number of atoms in that particular compound. What is the formula of sulfuric acid? It is H2SO4, isn't it? So, sulfuric acid contains two hydrogen atoms or otherwise two atoms of hydrogen, right? Sulfuric acid, H2SO4 is sulfuric acid. Sulfuric acid contains two atoms of hydrogen. See how many atoms of sulfur is present? It is only one. Okay. Yes means it mentions only one. Number is not given here. So it means only one sulfur atom. So, two hydrogen atoms and one atom of sulfur and four atoms of oxygen is present in sulfuric acid. First, you have to mention that one. That is the first point, right? Second one, we have to find out the relative molecular mass, isn't it? For which compound? For sulfuric acid. Then you have to mention relative molecular mass of sulfuric acid. That is equal to, what is the atomic mass of hydrogen? First element is hydrogen is given, isn't it? So what is the atomic mass of hydrogen? The atomic mass of hydrogen is 1, isn't it? Okay. See how many hydrogen atoms are present? 2 hydrogen atoms are present here, isn't it? So 2 into mass of hydrogen plus next one. How many sulfur atoms are present? Only one, isn't it? So 1 into mass of sulfur plus how many oxygen atoms are present? 4 oxygen atoms. So 4 into mass of oxygen. Okay, why you are adding this one? Because hydrogen, sulfur and oxygen combine together to form the compound sulfuric acid. So we are adding, right? So this is the next step. Final step is, already we know sulfuric acid contains 2 atoms of hydrogen, right? So 2 into mass of hydrogen. Mass is nothing but atomic mass. What is the atomic mass of hydrogen? It is 1, right? So 2 into 1 plus 1 into 1 means it means sulfur atom. 1 into, what is the atomic mass of sulfur? See the atomic mass of sulfur, it is 32. Okay. Sulfur atomic mass is 32 plus 4 into, that is 4 oxygen atoms. So 4 into, what is the atomic mass of oxygen? The atomic mass of oxygen is 16. Okay. You should learn the first 20 elements atomic number thoroughly, children, right? So first 20 elements atomic number is very important. Okay, right. So after getting this, after this step, what you have to do? 2 into 1, 2, right? 2 plus 32 into 1, 32 plus 16 into 4, 4 6 are 24. Remaining 2, 4 1 is 4, 4 plus 2, 6. Isn't it? 64. When you add these things, 64, 32 and then 2. So we'll be getting 98. Okay. So the relative atomic mass of sulfuric acid is 98. 98. Okay. So these steps, step by step, you have to mention. First, you have to mention the number of atoms present in the particular compound. Okay. Second step, you have to mention the number of atoms into mass of that particular element. Right. That's the second step. Final step, you have to mention the number of hydrogen, number of atoms in that particular compound, followed by you have to multiply it with the atomic number. That is the third step. Final step, when you add all these things, you will be getting the relative atomic mass. So 98 is the relative atomic mass of sulfuric acid. Okay, it means sulfuric acid is 98 times as heavy as carbon 12 atom. Okay, isotope of carbon 12 atom. So you just put the box like this, highlight the answer like this, right? Shall we move to the second one? Right. Second question is, second problem is calculation of molar mass. Okay, you have to calculate it grams. Why? Because it's given mass. Calculation of molar mass for carbon dioxide. CO2 means carbon dioxide, right? Okay. First, what you have to know for this problem, you should know the atomic mass of carbon as well as for hydrogen, right? So, atomic mass of carbon is equal to, so this is the carbon element. So, what is the atomic mass of carbon? Atomic mass of carbon is 12. Okay, right hand side corner, atomic mass is given in the periodic table, right? Next one, we have to find out the atomic mass of oxygen. Oxygen atomic mass is 16, right? 1/6. How many oxygen atoms are present here? 2 oxygen atoms, right? So carbon atomic mass is 12, oxygen atomic mass is 16. This is the first step, right? So next step, we have to calculate the gram molar mass, isn't it? So right, gram molar mass of which compound you are going to find out? You are going to find out for carbon dioxide compound, right? So gram molar mass of carbon dioxide is equal to, what is the atomic mass of carbon? It is 12. Okay. How many carbon atoms are present? Only one. So put it in the bracket like this. Plus, because carbon plus oxygen combines to form the compound carbon dioxide. So we are adding, right? So second one, you have to put the plus symbol. Next, what is the atomic mass of oxygen? It is 16. Now you have to check how many oxygen atoms are present. It is 2, isn't it? So 16 into 2. That is equal to 12 into 1. 12 plus 16 into 2, 32. So 12 plus 32, you will be getting 44 grams. Okay. This gram is very important. You have to mention the gram. Okay. So without this one, you won't get full marks, right? So unit is very important because in the question, you have to calculate it in grams, right? So the answer is 44 grams, right? So the next step, final step, you have to mention, isn't it? Therefore, gram molar mass of carbon dioxide, that is equal to 44 grams. Okay, you have to mention the last step, final step. Gram molar mass of carbon dioxide is equal to 44 grams. This gram is very important. Highlight the final answer. Got it? Right. So next question, find the mass percentage composition of methane. Okay, you have to find out the mass percentage composition of methane. What is the formula of methane? The formula of methane is CH4. It means carbon atom as well as hydrogen atom combines to form the compound methane. Right. So for that, first what you have to identify? You have to identify the molar mass of methane. For that, you should know the atomic mass of carbon as well as you should know the atomic mass of hydrogen. Okay. So first step, molar mass of methane. CH4 means methane. Okay. You write in full form molar mass of methane. In words you write. In the bracket you mention the formula CH4. Okay. Is equal 16 gram. Okay. So now you know the molar mass of methane. Next step, you have to find out the mass percentage composition, isn't it? For that you have to use one formula here. You have to apply a formula. What is that? Mass percentage of an element is equal to mass of that element in the compound. Okay. Mass of that element in the compound by molar mass of the compound. Right. So what are the elements are present in methane? It is carbon as well as hydrogen. Both the elements are present, isn't it? Divided by molar mass of the compound. This formula you have to apply to find out the mass percentage. Next step, first you have to find out the mass percentage of carbon. Okay, because carbon is given in the first, isn't it? So first you have to find out the mass percentage of carbon. So mass percentage of carbon is equal to, what is the atomic mass of carbon? This 12 is carbon atomic mass and the hydrogen atomic mass is 1, isn't it? So put the 12 divided by 16. Already you know the molar mass, isn't it? Mass of that element in the compound means now we are applying for carbon element. Okay. Carbon atomic mass is 12 divided by what is given here? Molar mass of the compound. Already we find out the molar mass, it is 16 grams, isn't it? So 12 divided by 16 into 100. 12 into 100, 1200 divided by 16, you will be getting the percentage 75. Okay. So now you know the mass percentage of carbon, that is 75%. Next what you have to do? You have to calculate for hydrogen atom, isn't it? Right. For that the same formula you have to apply here. Right. Mass of that element means it mentions hydrogen element. What is the atomic mass of hydrogen? It is 1. How many hydrogen atoms are present? 4. So 1 into 4 will be getting 4. So mass percentage of hydrogen is equal to 4 divided by molar mass of the compound. Already you know the molar mass, it is 16 grams, isn't it? So 4 divided by 16 into 100. Why 100? Because you are going to convert it into percentage, right? So into 100, that is equal to 400 by 16. You will be getting the percentage 25. Okay. So if you add 75 plus 25, you will be getting 100%, right? So this formula you have to apply to find out the percentage for hydrogen or carbon as well as hydrogen, right? Next question is, find the percentage of nitrogen in ammonia. The same method we have to follow for this problem also. Okay, only the question is differing. See, find the percentage of nitrogen in ammonia. In this problem, we find out for both the elements, carbon as well as for hydrogen, isn't it? But in this problem, you see, find the percentage of nitrogen in ammonia. What is the formula of ammonia? Formula of ammonia is NH3. For this NH3, they ask you to find out only the percentage for nitrogen, not for hydrogen. Okay. So learn the question 1 or 2 times. Read the question 1 or 2 times and only you can understand the problem first. So no need to find out the percentage for nitrogen as well as hydrogen. In the question they have asked to find the percentage of nitrogen in ammonia. For nitrogen only you have to find out the percentage, right? Okay, right. So for first step what you have to do? Percentage of nitrogen in NH3. NH3 means ammonia. You have to write in words. Okay, ammonia. In the bracket only you have to use the formula NH3, right? Now next step, what is that? Mass of nitrogen divided by molar mass of ammonia. Okay, here already we have applied the same formula only. Mass of that element in the compound. Which element we are going to use? For nitrogen element, isn't it? So mass of nitrogen by molar mass of ammonia into 100. Okay. So what is the mass of nitrogen? Nitrogen atomic mass is 14. Okay. Nitrogen atomic mass is 14. It is given in the periodic table, right? So 14 divided hydrogen atoms. So 14 plus 3 you will be getting 17. Okay. So 14 divided by molar mass of ammonia. For that you have to find out the molar mass for the whole compound, for this compound, not only for nitrogen, even for hydrogen also. So you have to add both the atomic mass, you will be getting the molar mass. So 14 atomic for nitrogen, its atomic mass is 14. For hydrogen, atomic mass is 120, but 3 hydrogen atoms are present. So 14 plus 3 you will be getting 17. Okay. So 14 divided by 17 into 100, that is equal to 1400 by 17. That is equal to, if you divide this, you will be getting 82%. So the percentage of nitrogen in ammonia is 82%. Final step you have to finish like that, children. Okay. So the formula is very important. Another thing is you should get familiarized with the first 20 elements atomic mass. Okay. Then only you can apply this formula. Then only you can get the final answer. Got it, children? Right. Yes. Next we can move to calculation based on number of moles from mass and volume. So calculation based on number of moles. Okay. Calculate the number of moles of a sample that contains 12.046 into 10 to the power 23 atoms of iron. Right? Once again I repeat the question. Calculate the number of moles of a sample. We have to calculate the number of moles that contains 12.046 into 10 to the power 23 atoms of iron. Okay, what we are going to calculate? We are going to calculate the number of moles, right? For that, we have to apply this formula, that is number of moles is equal to number of atoms of iron divided by Avogadro's number. Okay, because we are going to find out the number of moles. So, number of moles is equal to number of atoms of iron divided by Avogadro's number. Okay, that is equal to, already it is in the question they have given the number of atoms of iron, isn't it? So, this is the number of atoms of iron. So 12.046 into 10 to the power 23. Okay, divided by this formula we have to apply. Number of atoms of iron is 12.046 into 10 to the power 23 divided by Avogadro's number. Avogadro's number is 6.023 into 10 to the power 23. That you know, isn't it? Okay, divided by, you put the Avogadro's number. Okay, this is the division, isn't it? So you strike out these two things. Next step, you have to divide 12.046 divided by 6.023. If you divide this, the final answer you will get is 2 moles of iron. Okay, the final answer is 2 moles of iron. First, what you have to do? You have to apply the formula. Number of moles is equal to number of atoms of iron divided by Avogadro's number. Number of atoms of iron is given in the question. Divided by, you put the Avogadro's number, right? Okay, so the 10 to the power 23, here also 10 to the power 23 is in the division, so you cancel it. Then again divide this 12.046 divided by 6.023, you will be getting 2 moles of iron. Okay, highlight the answer. Next question. Calculation of mass from mole. Calculation of mass from mole. That is 0.3 mole of aluminium is given. Okay, 0.3 mole of aluminium is given. We have to calculate the mass from this mole. Okay, atomic mass of aluminium is already given in the question 27. So where is aluminium? See, here is aluminium element. Its atomic mass is 27. Sometimes atomic mass will be given in the question itself, but sometimes, many times they won't give you. You have to know the atomic mass. Already I told you, first 20 elements atomic mass you should familiarize, right? Okay, so in the question atomic mass is given of aluminium. For each and every problem, you have different formulas will come. Okay, based on the question, you have to frame the formula. Here, what they have asked: calculation of mass from mole. Mole is given. From this, you have to calculate the mass. For that, you have to apply this formula. Number of moles is equal to mass of aluminium divided by atomic mass of aluminium. Okay, because aluminium element they have given in the question, isn't it? Right. So mass, you know very well, you have to take the known things in one side and unknown things in another side, isn't it? Right. We don't know the mass of aluminium, isn't it? So you just take it as in the left hand side. Mass is equal to number of moles into atomic mass of aluminium. Right. You take this mass the left hand side. So next, number of moles into atomic mass. Okay. Now mass of aluminium is equal to number of moles. Number of moles, it is already given in the question. This is the number of moles, 0.3. Okay, 0.3 into what is the atomic mass of aluminium? Atomic mass of aluminium is 27. It is given in the question, right? So 0.3 into 27. If you multiply this, you will be getting 8.1. Okay. The question what they have asked: calculation of mass from mole. Mass means you have to mention the unit. It is in gram. Okay. So 8.1 gram. This is the final answer. Right. Once again I repeat. Number of moles is equal to mass of aluminium by atomic mass of aluminium. Mass of aluminium is mass of aluminium we don't know. Okay, so we take it in the left hand side. Number of moles into atomic mass, that is equal to mass of aluminium. So mass of aluminium is equal to number of moles is 0.3 mole into what is the atomic mass of aluminium? It is 27. If you multiply this, you will be getting 8.1 gram. Right? Next problem we can see now. How many grams are there in the following? Okay, you have to calculate in grams. How you have to find out the answer in grams. How many grams are there in the following? First question: 2 moles of hydrogen molecule. From this 2 moles of hydrogen molecule, you have to find out how many grams are present. Okay, the question is 2 moles of hydrogen molecule. So that is H2, right? Next step we have to find out the molecular formula because they have asked in moles. So molecular mass of H2. H2 is hydrogen, right? Molecular mass of H2 is equal to 2. How? Because atomic mass of hydrogen is 1. How many hydrogen atoms are there? 2 hydrogen atoms. So 1 into 2, you will be getting 2. Molecular mass of hydrogen is equal to 2, right? Next step, we have to apply mass is equal to number of moles into molecular mass, right? Mass is equal to number of moles into molecular mass. Okay. What's the number of moles they have given in the question? It is 2, right? So 2 into what is the molecular mass of hydrogen? Molecular mass of hydrogen is 2. So put 2 into 2, you will be getting 4. And what is asked in the question? How many grams are there? So you have to put the unit gram. Okay, 4 gram. Right. So this is the answer. Next question, next one, the same thing only. 3 moles of chlorine molecule. Here molecule only differing. Okay, here we saw hydrogen molecule, isn't it, in the first problem. Second, we are going to see the chlorine molecule, right? For first step, what we have to do? We have to calculate the molecular mass of chlorine, isn't it? For that, you should know the atomic mass of chlorine, isn't it? What is the atomic mass of chlorine? See, the atomic mass of chlorine is 35.45. This is chlorine element. The atomic mass of chlorine is 35.45, right? We have first step, what we have to do? We have to find out the molecular mass of chlorine, isn't it? So write molecular mass of chlorine. Write inverse chlorine. In the bracket you put Cl2. Here there is no space, that's what I have written like this. Okay, you should write in words, you should mention it in words, but also in the bracket you should mention the formula. That is very important. So molecular mass of chlorine is equal to, what is the atomic mass of chlorine? What I told now, 35.45. How many chlorine atoms are present? It is 2, isn't it? 2 chlorine atoms are present. So 35.45 plus 35.45, you will be getting 70.90. So this is the molecular mass of chlorine. In this manner, you have to calculate find out the molecular mass of chlorine. Okay, right. So molecular mass of chlorine is equal to 70.9. Next step, what you have to do? You have to find out the mass, isn't it? So mass is equal to number of moles into molecular mass, right? Mass is equal to number of moles into molecular mass. What is given in the question? You have to find out 3 moles of chlorine molecule. Okay, 3 moles of chlorine molecule. So number of moles is 3 into, what is the molecular mass of chlorine? It is 70.9. So 3 into 70.9. If you multiply these two, you will be getting 212.7. Right, 212.7. You have to find out in grams. How many grams? You have to calculate it in grams. Okay. So you should mention the unit gram. 212.7 gram. I write the answer like this. Right. Next one. 5 moles of sulfur molecule, that is S8. It means it contains 8 atoms of sulfur, right? 5 moles of sulfur molecule. For that, what you have to know? You should know the atomic mass of sulfur, isn't it? As sulfur element, here see, this is sulfur element. What is the atomic mass is given? It is 32. 32. Okay, right. First step, what you have to do? You have to find out the molecular mass, isn't it? For which molecule? For sulfur molecule. So molecular mass of sulfur molecule is equal to 32. What is the atomic mass of sulfur? It is 32. How many atoms are present? 8 atoms are present. 8 sulfur atoms are present, isn't it? So 32 into 8. Okay, if you multiply this, you will be getting 256. Okay, what answer you get? You will get 256. The next step, what you have to do? You have to apply this formula. Mass you have to find out, isn't it? You have to find out the mass now. So mass is equal to number of moles into molecular mass. This formula you have to write. So mass is equal to 5. 5 means it is given in the question. You are going to find out the mass for this 5 moles. Okay. 5 moles of sulfur molecule. So, you have to, number of moles is given, that is 5 into, what is the molecular mass of sulfur? The molecular mass of sulfur is 256. So, 5 into 256. If you multiply this, you will be getting 1280. Also mention the unit, it is in gram. Okay, 1280 gram is the answer for sulfur molecule. Like this, you have to calculate. The very important thing is you should remember the atomic mass. Without atomic mass, you cannot solve any of this problem. Right, children? Right. The next problem is calculate the percentage of each element in calcium carbonate. Okay, I repeat the question. Calculate the percentage of each element in calcium carbonate. Right. First, you should know the formula of calcium carbonate. Okay. So it is CaCO3. CaCO3 is calcium carbonate. Right. So calculate the percentage of each element in calcium carbonate. At the same time, the atomic mass is given in the question itself, right? Atomic mass, chlorine is equal to 12, oxygen is 16, and for calcium it is 40. This is given in the question itself, right? What is the next step? See, in the calcium carbonate, right? Okay, so next step we have to find out the molar mass, isn't it? First we have to find out for calcium element, right? So what is the atomic mass of calcium? It is 40. Okay, first Ca. So put 40 plus carbon atom. For carbon atom, what is the atomic mass? It is 12 plus 12 plus oxygen. What is the atomic mass of oxygen? Oxygen atomic mass is 16, right? How many oxygen atoms are present? 3 oxygen atoms are present. So you have to put 3 into 16, right? This is the first step. Molar mass of calcium carbonate is equal to calcium atomic mass is 40, carbon atomic mass is 12 plus oxygen atomic mass is 16. At the same time, 3 oxygen atoms are present. So inside the bracket you put 3 into 16. This step over. Next step, put 40 plus 12. 3 into 16 you will be getting 48. If you add this, you will be getting 100. Okay, right? Next step, you have to find out the percentage of carbon. What is asked in the question? Calculate the percentage of each element. So you have to calculate the percentage. You have to find out the percentage for calcium, for carbon, as well as for oxygen. Okay, because these three elements only present in calcium carbonate, isn't it? Right. What is the first element is given? It is given calcium. Right. So percentage of calcium in calcium carbonate is equal to mass of carbon by molar mass of calcium carbonate into 100. Why? Because you have to calculate the percentage only, isn't it? So you put 100. What is the formula you have to use? Percentage of calcium by percentage of carbon in calcium carbonate is equal to mass of carbon by molar mass of calcium carbonate, right? Into 100. First you have to find out. This is a whole compound calcium carbonate. For that you have to calculate for carbon first. Okay, mass of carbon by molar mass of calcium carbonate into 100. So carbon atomic mass already is given in the question itself, right? So next what you have to do? Mass of carbon. What is the atomic mass of carbon? It is 12, right? So 12 divided by, what is the molar mass of calcium carbonate? This is the molar mass of calcium carbonate. Molar mass of calcium carbonate. Okay, so 100 is the molar mass of calcium carbonate divided by 100 into percentage into 100. So you will be getting 12 into 100, 1200 divided by 100. Cancel these two zeros, you will be getting 12%. Okay, so now you know the percentage of carbon in calcium carbonate, right? You know the percentage of carbon in calcium carbonate. Next what you have to find out? You have to find out the percentage of oxygen. First one for carbon, second one for oxygen. Percentage of oxygen in calcium carbonate. The same formula you have to use. Instead of this carbon, what you have to write here? You have to mention oxygen. Okay, right. So percentage of oxygen in calcium carbonate is equal to mass of oxygen by molar mass of calcium carbonate into 100. Okay, that is equal to, what is the mass of oxygen? What is the mass of oxygen? The mass of oxygen is 3 into 16, 48. This is the mass of oxygen, isn't it? So put mass of, don't simply write 16. If you put 16, then you will get wrong answer only. So you have to count the oxygen atoms also here. 3 oxygen atoms are here. So 16 into 3, that is the molar mass. Okay. So mass of oxygen divided by molar mass of calcium carbonate into 100. Mass of oxygen is, this is the mass of oxygen, 48 divided by, what is the molar mass of calcium carbonate? Molar mass of calcium carbonate is 100 divided by 100 into percentage. That is 14 into 100 you will be getting 4800 divided by 100. Cancel the zeros. What you are getting? You are getting 48%, right? So next what you have to do? You have to calculate the percentage of, now you know the percentage of carbon as well as percentage of oxygen you know, isn't it? Now percentage of calcium in calcium carbonate. Okay. For all the three elements you have to find out. Already you know two elements, the last element. The same formula you have to apply. Instead of here, you have to write calcium. Mass of calcium, percentage of calcium in calcium carbonate is equal to mass of calcium by molar mass of calcium carbonate into 100. Okay, that is equal to, what is the mass of calcium? The mass of calcium is 40. 40 divided by molar mass of calcium carbonate, it is 100. It's a common thing for all. Okay. By 100 into percentage. So 40 into 100 will be getting 4000, isn't it? So cancel these zeros. What you are getting? 40%. Separate you have to find out the percentage for each element. What are the elements are present here? Separately you have to find out the percentage. This is the steps you have to follow. In this manner only you have to follow, right? Once again I tell you, first you have to, atomic mass is already given in the question. You have to find out the molar mass first. Molar mass of the particular compound, calcium carbonate, you have to find out. Next what you have to do, you have to separately find out the percentage for calcium, percentage for carbon as well as percentage for oxygen. Okay, in this manner you have to do. Next problem is calculate the percentage of oxygen, who means oxygen, in Al2SO4 thrice. Okay, calculate the percentage of oxygen in Al2SO4 thrice. So here no need to find out the percentage for all the elements what is present in aluminum sulfate. Okay, you have to find out the percentage only for oxygen. Right? Only for oxygen you have to find out. So first atomic mass is given in the question itself. Atomic mass for aluminium is 12, as well as oxygen is 16 and sulfur is 32. Okay. So what you have to do? Molar mass of aluminium sulfate. Molar mass of aluminium sulfate. Atomic mass is wrongly given, it is 27. Carbon atomic mass only 12, right? So atomic mass of aluminum is 27. For oxygen it is 16 and for sulfur it is 32. Okay. Next you have to find out the molar mass of aluminium sulfate, right? Molar mass of aluminium sulfate you have to find out. Next what you have to do? Molar mass of aluminium sulfate is 27 into 2. What is the atomic mass of aluminium? The atomic mass of aluminium is 27 into how many aluminium atoms are present here? 2 into 2 plus sulfur. Okay, what is the atomic mass of sulfur? It is given 32. Okay, so 32 into, see here SO4 thrice is given, isn't it? This thrice is for all this sulfur atom as well as for oxygen atom, right? So you have to put 32 into 3 plus, next what is given? Oxygen. What is the atomic mass of oxygen is given? It is 16 into, here already 4 oxygen atoms are present. Here thrice is given, isn't it? So 4 3s are 12. So 16 into 12. Once again I repeat this one. Molar mass of Al2SO4 thrice. For aluminium the atomic mass is 27. So 27 into 2 aluminium atoms are present into 2 plus next sulfur atom atomic mass is 32. So 32 into 3 SO4 thrice is given, isn't it? This thrice is for all the sulfur as well as for oxygen atom. So 32 into 3 plus next oxygen atom atomic mass is 16. 16 into, here already 4 atoms are given, here thrice is given, isn't it? So you have to multiply 12. So 27 into 2 you will be getting 54. 32 into 3 you will be getting 96. 16 into 12, answer is 92. If you add these things, you will be getting 342. So now you know the molar mass of aluminium sulfate. This is the molar mass of aluminium sulfate, right? So next what is asked in the question? You have to find out the oxygen in Al2SO4 thrice, isn't it? So mention percentage of oxygen in Al2SO4 thrice, that is equal to mass of oxygen in compound by molar mass of Al2SO4 thrice into 100. Okay. So next step, what is the mass of oxygen in compound? This is the mass of oxygen. This is the mass of sulfur. This is the mass of aluminium. Okay. So what is given? It is 192. So put 192 divided by molar mass of Al2SO4 thrice. Okay. What is the molar mass? It is 342. 192 by 342 into percentage. So if you multiply 192 into 100, you will be getting 19,200 divided by 342. If you divide this, you will be getting 56.14 percentage. Okay, 56.14 percentage is percentage. The percentage of oxygen in aluminium sulfate is 56.14 percentage. So read the question twice, then only you can get one idea. Okay, what are the things we have to find out? Like that, you have to find out. The main thing is you should know the atomic mass. For few questions, they will be given the atomic mass to you. The remaining things you have to learn it, right? You will be today you will get the assignment, children. So mainly you will get the book back question answers. All the 1 mark question answers including choose, Phillips, match the following, assertion and reason, true or false. If false means you have to correct the statement, and then short answers, detailed answer, higher order thinking questions. Everything you will be getting today. Complete it, then only you can prepare well for the unit test 1. Okay. Thank you, children.